Okay, so when I log into DataCamp, this is what it looks like for me. I'm assuming it looks like this for you, but I don't know. Maybe it looks different because I've got a teacher account, okay? And so what I'm gonna do is I go over to this page, Organizations, and these have all of my other classes, but you should have one here for Stats 21. And then you should be able to come over to Assignments. On the left-hand side, it should have Assignments. And then so this one is due April 17th, 23:59. So that's 11:59 tonight, okay? So if you haven't done it, you have another, I guess, 9 hours and 50 minutes, okay, to complete the intermediate Python course. So if you haven't done that tonight, please work on that. Okay. It says, for problem 1 on the homework, do we also have to print out the code or just write down the error messages and explain? Yeah, you can just write down the error messages and explanation. That's fine. That's fine. Okay, are there questions on this? Let me, all right, and then I will create your second homework assignment. It's mostly going to be exercises from the textbook, okay? I think the exercises in the textbook are actually very well designed, and they're very good. And I'm gonna have you work through them. Now, here's the thing. A lot of the exercises in the textbook already have solutions. They'll say right there in the exercise itself, it'll say, you know, the solution, you can find it at this web address, okay? So you know, the homework is for your benefit, okay? It really is. It's not, I don't care, like, I don't get any enjoyment or pleasure out of, you know, I mean, it's neat to see some of these pretty fractal patterns drawn and stuff, but the homework is for your benefit, okay? Do we need to submit the IPyNB file for the homework? I recommend, yeah, submitting both the output. So definitely you must submit the output file, okay? And then you might as well submit the IPyNB as well. But you know, I'm a little bit, I'm not gonna list it as a requirement for the first homework assignment. What's the output file? So the output file is the file that has all of your answers and the output of the code, right? So this is no good. So look at my slide here, okay? On my, my thing, I've got a notebook. If you turn it in like this, you're not gonna get any points. You're not gonna get any points because there's no output associated with the cell. You have to at least run the cell. And if it says something like, you know, show what the result is, we need to be able to see this result, okay? If it just looks like this and you just have code and there's no output associated with the with your cell, you're not going to get credit, okay? We don't have the luxury of loading up everybody's notebook, okay, and then running through all the code and then checking all the output, okay? That's gonna, the reader has to, you know, grade, you know, there's 70 of you here, and if you add, you know, loading, you know, that, because it's going to require deleting the old person's homework 2 file, loading in yours, and then booting up Jupyter Notebook, and then running all the code, you know, you're adding a couple minutes of time for each thing. So that's a couple minutes times 70, that's a couple hours. So, so don't add hours of work to our grader. Do you have to name the file like this? It's probably good if you do. You know, I wasn't as specific with my instructions for this homework assignment, so I'm going to let things slide a little bit. I think for the next homework assignment, I'll be a little bit more detailed in my instructions, and then I'll expect students to follow the instructions that I detailed.
Can I ask a question about
go for it.
For number 3, you say like make sure to put like whatever output like when possible.
Mm-hmm.
I just want to ask like for that question, what output are you looking for like for the specific questions?
I forget exactly what number 3 was asking. Can you just remind me?
Yeah. 1 second. Okay, so number 3 said it was like the one with a couple like operations. It asked like A was we've seen that n equals 42 is legal. What about 42 equals n? And the next one asks if x equals y equals 1 is legal. And the next one asks about a semicolon and then like a period. So I want to ask what kind of output you're looking for those questions.
Oh, just a text answer. So.
Oh, okay.
Yeah.
Okay, thank you.
Yeah. So if it's something like, so you know, this first homework assignment's a little bit like loose, and it's very light on actual coding. It's just kind of like, hey, let's look at some error messages in Python and stuff, right? It's this first homework assignment was intended to be fairly easy, intended to just give you a very gentle introduction to Python, and so that's where we're starting. Okay, so you know, as far as what we've done in our course so far, the very first week we spent a bunch of time on Git and GitHub, and I think that's a useful skill to have. And then the second week was very like gentle. Let's start talking about Python, and let's start talking about coding concepts and reading error messages. And I think that's fine. You know, this first homework assignment should be a slam dunk for everyone. Okay, as long as you've done it. And then these next couple homework assignments will be a little bit more code intensive. The intention is to give you exercise to get better, right? So just like going to the gym and whatnot, if you don't do the exercises, you can't expect for your strength or your coding skills to improve here, and that's what we're going to do. I know that some of the answers are already provided, okay, and it's not hard to go on the internet and search for answers to some of the problems, even if an answer is not provided. Okay, I really want to strongly encourage you to avoid that temptation, because you know, I imagine you enrolled in this course so that you can learn Python and so that you'll gain some skills. The homework challenges, the homework exercises, you know, some of them will be a little bit challenging, but they're not meant to be so out of reach that, you know, you have to get someone else to do your exercises for you, right? You know, if you get stuck on a problem, that's fine. All right, just take a break from the problem and let it fester in your brain for a little bit, right? And then a lot of times, you know, you're gonna have weird coding dreams sometimes, and the answers will come to you while you're sleeping, and it's a great feeling. Okay, I'm totally serious. Stuff like that happens. Okay. And others of you, you're gonna sit down and you'll be like, oh, this is so easy, and you'll get your answer. Okay, but you know, if you're new to this coding stuff, like, and you have to think about recursion, it's gonna be a little. All right. Q5 in homework 1, Q5, should the output theta be in radians or degrees? I don't care. Okay, these were simple exercises. You know, we're not sending robots to Mars where this kind of mistake is going to make a difference. Okay, you know, as we go on, I'll be a little bit more specific. You know, I know it feels weird, especially if you're coming in this class and you just took like 102A and stuff, where I'm like giving all of this stuff, right? This is Stats 21. It's intended to be, you know, lower div, a little bit more gentle in this regard here. So it's okay. All right. Is that okay? Is that okay? My attitude for this stuff. Okay. The first homework intended to be easy and gentle. Okay. Next ones are going to be a little bit more coding intense, and we're going to keep cranking up the heat for your coding intensity. Okay. And again, a little bit of coding several times a week is much better than trying to do everything in one sitting. And then, and do your best. Do your best to figure out these solutions on your own. I know the solutions are out there, but try to resist that temptation. Think of it as completing a puzzle or working out at the gym. You want to do these things yourself rather than looking up answers. All right. Okay, so I wanted to talk a little bit more about lists. Lists will come later on in the textbook, but as far as some of the exercises go, so I was going to assign exercises from the textbook, and I was going to assign a couple exercises of my own, and so I wanted to introduce you to lists now, and then we'll also kind of just gloss over what the textbook has to say about lists later on. Okay, so earlier we talked about subsetting lists and slicing lists, and so here I want to show you a couple list methods. And so we have list.copy, which we saw earlier, and that's equivalent to this. And then there's list append, okay? And what list append does is it takes a new thing and it just tacks it on to the end of the list. So here I've got this list with Liz, Emma, Mom, and Dad. And we're going to say append the entry me, okay? And so what I wrote here is that unlike R, you don't have to actually like capture the result of a function, okay? So in R, anytime you did a function, it always produced a copy. And if you wanted to have that like modify something, you needed an assignment operator. Anytime you wanted to modify the object, you needed to have an assignment, okay? Here you can just say append me to the list fam, and the list itself is appended, or the list itself is modified, okay? And so when we print out fam, we can see that the entry me has been tacked on at the end, okay? You can also take a list and do plus, and then you put some kind of entry in square brackets, and that will append the list as well, okay? Except in this case, this is going to return a new object, and so in this case, you do have to capture that output in that you have to assign it back to fam, okay? So notice here there was no assignment operation, but here I have to do this and I assign it back to fam, okay? And so there we've appended the value 1.8, but notice the difference between this cell and this cell, okay? So here we go. Here's our, here's this. Here I can append this entire list, okay, to this, and notice what happens. Whoops. This, okay, if I try to do append, okay, it appends the list itself, okay? So here is the list that we had earlier, and then now we have one new entry in the list, okay? So that's probably not what we wanted. So append only allows you to take one object, and it puts that entire object into the list, okay? So this is what we've got. And so if you wanted to do something like this, then the plus operator is probably what you're going for, okay? So here, notice the plus operator doesn't insert the list itself, but it kind of concatenates the two lists together. So it combines the two lists. So so append, maybe I'll note this, append will add the entire object as one list entry, okay? Whereas the plus operator kind of concatenates the list, which is probably what we want. But again, if you don't do an assignment operator, the original list remains unchanged, okay? So if you don't take this and capture it and assign it somewhere, the original list is unchanged. Okay. List insert will take one object and insert into position I, okay? It's going to insert it into position I. And so, so here, it's going to insert it into the index 4 position, okay? So if we look at where's the index 4 position, it's going to be in between 1.68 and mom. So Joe is going to go right in between 1.68 and mom. And so when we do that, it goes right there, okay? And so again, the insert modifies the list itself. We don't have to capture it. We don't have to assign the results of this back to FAM. It modifies FAM itself. It modifies the list itself, okay? If you try to insert a list, okay? If you try to insert a list, kind of like append, it inserts the entire object, okay? So this is probably not what you wanted, okay? Here it inserts here, but you can see that there's still square brackets around it. And so I'm recording, right? Yeah, okay. So now we have the list, but you've got another list object inside, okay? And if you try and you say, well, okay, maybe I will take off the square brackets, right? And you try to do this, this causes an error, okay? It says insert takes exactly 2 arguments, okay? The position and the object, and you gave it 3, okay? And it says, I'm mad at you. So, so it doesn't let you do that, okay? So there's a couple workarounds, or not workarounds, but there's a couple ways to achieve what we want to do, okay? So one is you can do an extend, okay? Extend is very much like this operation where I did use the plus operator, okay? But extend will always put it at the end. So it's going to take this list and extend the original list with these two items. And so it's going to extend the list by adding Joe and 2.0, this list on the end. So it's kind of like using that plus operator, okay? Or the other thing is you can use assignment in conjunction with slicing, okay? So here we're going to say take Joe 2.0, and we're going to assign it to the list slice 4:4, okay? So we say, all right, well, where's 4:4? 4 is would technically be an empty list right here between 1.68 and mom, and we're going to assign Joe and 2.0 into that list slice. And when I do that, Joe and 2.0 will get assigned right into that list slice, okay? And so this is one way to achieve kind of the idea of inserting list elements into kind of the middle of a list, right? Probably what you're going to be using frequently is extend, or the plus operator. The plus operator is just so convenient, and I think our brains kind of like it. It's easy for our brain, If you use lists frequently, you're going to end up memorizing all of these methods, okay? But especially when you're new to Python, you're like, oh my gosh, how many of these things are there, right? Append and sort and all of these. Extend. It can be overwhelming learning all of the methods, right? That's okay. You'll get it, right? List remove will remove elements out of the list. Again, it modifies the list itself when we do it. Okay, that's why at every cell I have to like redefine the list every time because every time I need to because every time I run one of these operations, the list itself gets modified. So here we said remove the entry Liz, and it does that. Okay, so this is the result. Okay, again I have to redefine the list here, and then there is there's a method called pop. Okay, pop will what we call pop the last item in the list. Okay, and is there a way to remove every item from list whose value is X? I don't think so. I think you can, there's not a method that just does it quickly. You can kind of find out which elements in the list are equal to something, and then you can kind of assign none to those things, I think. Well, I gotta think about this. I gotta think about this for a second, okay? But yeah, list remove, we'll just remove the first one, okay? Pop will return a value, okay? So here, when I run this, I can actually assign the value that it returns to something, okay? And so when I run this, it's going to return the very last item, and then the list fam itself will be modified to everything but that last item. So it's gonna print out 1.89, that was the value that got popped, and the family list is everything without that 1.89, okay? If you, you can also give pop an index, like 0, and here it's gonna pop the first value, and it's gonna return, that. So J will now take on the value Liz, and then fam will have everything without Liz, okay? And then the last method is just clear, and that just empties out the list, okay? So here, it gives us back Liz, it gives us back everything that's left, and then clears everything out, okay? There's index. Index will return the index value, the zero-based index value in the list of the first item whose value is X. Okay, so if you have multiple things in here, it's only going to give us the first one. And then count will give you how many times a value appears in the list. Okay, if I'm sorry, and then one more thing about index is that if there's no such term, you're going to get back an error. Okay. So here I've got, what is the index of Emma? It says 2. If I say fam.index and I ask for 3, it's going to give me back an error. It's going to say 3 is not in the list. Okay. Here we've got count, and it's going to say how many times does A appear in this list? It tells me it appears 3 times. Okay. And so here I've got the list of lists. Fam2 is a list of lists, and we say, okay, where does Emma appear? Okay, Emma is not an entry in the list itself. Okay, but the is not an element of the list, but the list containing Emma and 1.68 is an element in there. So that's going to give us back a value there. All right, there is. There's reverse. Reverse will modify the list in place. Okay, so here is here's the list if we reversed it. Okay, sort will sort the list in place. Here I'm going to get an error because you can't sort floats and strings together. All right, it says that's not allowed. Okay, but here I've got a list of just some arbitrary numbers here. Okay, and I do have a float in here, even though the rest are integers. Okay, and it does. It's going to sort it in place, and here's the list after it's been after we sort it. Okay. And it preserves the data type, so it doesn't coerce them into, or I'm sorry, in Python we call it upcasting. Okay, R we call it coercing, and in Python we call it upcast. It doesn't upcast all the values into floats. It leaves them as integers if they're integers. It leaves 5.1 as a float. Okay, and so we can ask, what is this? This is type of this is still a float. Okay. You can sort them in reverse order, all right, and it does that, okay. Whereas here, if I call sorted on the list, okay, sorted will return a copy that has been sorted, all right, whereas it will leave the original list unchanged, right? So here's the original list, some digits, and I think I showed this in one of the early lectures when we were talking about naming functions, and you have, we named the function sort to be sort, so it's going to actually modify the object, modify the list itself, and then whereas something that returns a copy, we named it sorted. Okay, so so it returns a copy that has been sorted, but it doesn't actually sort the list itself. So so these are things that you have to, especially if you're coming from R. These are some behaviors that you have to get accustomed to. That Python will sometimes modify the object itself, and in other cases it will return a copy, and you just have to be aware of the behaviors of each of these functions. All right, I'm going to now go through the chapter 6 in the textbook, looking at these things. And chapter 6 is titled Fruitful Functions, and the idea that we've written a function and the function is going to return a value. It's going to produce a fruit, a value that's been returned. But we've actually already talked about how functions return values. But there is a lot of good information in chapter 6 talking about incremental development, okay? And so, again, highly recommend reading the actual textbook, okay? Read through your PDFs or whatever, because the notes and the strategies and tips given there are very useful, and it's a quick read. So so anyway, this is always something that you should do when writing code. Okay, this is one of the biggest mistakes I see beginners do, is that beginners will try to code everything all at once. Okay, and when you're an expert, sure, you can start doing that. Okay, but especially if you're new to coding, truly code incrementally. Okay, start with the most basic version, and then just add a couple lines at a time. Every time you add something, try out a test case to see if it works, and then and if it works the way you expect it to, then you can move to add another piece of code, right? So incrementally, we can write the distance function. This one's probably so simple that you can just write it in one go. But again, just to kind of belabor the point of writing incrementally, start by just defining the function and have it return nothing, or have it return 0 here, okay? Obviously this is wrong, but we can just say, all right, define the function distance, and it's going to take 4 inputs, x1, y1, x2, y2, and it's going to compute the Euclidean distance between these 2 points. And then we'll try to execute it on just a set of points, and return 0, which is obviously wrong. But then, you know, it'll also give you a sense of like, okay, what if you give it the wrong number of arguments? Okay, then we're going to get some kind of error, right? It says we're missing a required positional argument, right? So just by writing very basic things and then running into errors, and that's running into errors often feels like, oh, we want to avoid errors, and that is true, we do, but running into errors and then carefully reading the error message will also help you avoid those errors in the future. So you say, oh yeah, that was silly, I've left off an argument, right? The argument function requires 4 values, and I only gave it, I only gave it 3 of them. So of course we're going to get an error, right? Okay, and then so we'll incrementally build this up. And so the next few thing that we're going to do is we're going to calculate kind of the difference in x, and we're going to calculate the difference in y, right? And so especially when you're building a complex function, it is helpful to write intermediate values, right? So in this case, I'm going to create an intermediate value called difference in x, which will be x2 minus x1. And then we're going to create an intermediate value difference in y, dy, y2 minus y1. And then as part of kind of the debugging strategy, you can add print statements, okay? And some people laugh at using print statements. Again, another meme. I'm sure that I'm always finding let's see, print statements meme. Yeah, exactly. Print statements everywhere. This is just how we do it, okay? And there's nothing nothing wrong with it, okay? There's another one where I don't know, it's like stop using print statements for debugging, or draw 25, and is like playing Uno and the guy has, you know, a bajillion cards. So and it's fine, okay? And so if you keep printing out the values, your intermediate values, all right, it's a good way to make sure that the function is behaving the way you want it to function, right? And so, right, because it's easy to make a small mistake, like, right? So let's say you make a typo, right? You make a typo like this, x2 minus y1 for dx, and y2 minus y1 here, okay? And this kind of mistake is not going to throw an error, okay? It's not going to throw an error, but it's not going to give you the result that you want, okay? And in your debugging, it can become very frustrating. Why is my function not working, okay? And it's just because you made a small typo, right? And these kinds of typos can be hard to detect. And so here, when you test it out, okay, you say, all right, what I should get when I'm going from 1 to 4, I should get a distance of 3, and going from 2 to 6, I should get a distance of 4. And by having this print out the intermediate values of dx and dy, and it says dx is 2 and dy is 4, we say, well, it shouldn't be 2. It should be 3. Why am I getting 2? Then you go back into your code and you go, oh, that's why. I made a small typo here, okay? And it should be x2 minus x1, and now this is returning what I want, okay? So just by adding little print statements that return intermediate values, okay? And anytime you run a print statement, you should declare something like dx is equal to this value, so at least you know what this is referring to. Otherwise, if you didn't include this, it's going to be much less helpful. If you have something like this, you know, you're going to just have 3, 4, and you're going to be like, well, I forgot what I was trying to say. Okay, so much less helpful. So always add stuff, and this kind of strategy will help you avoid things, right? Especially when you're building bigger programs. It's easy to make a small mistake that's not a syntax error, that's not going to throw an error, but it's going to mess up the calculations later on, and you're going to be wondering, why am I not able to calculate the value that needs to go? Okay, all right. So you run some test cases and you go, okay, this is producing what I need to produce, right? So of course, the other part, as far as testing goes, is when you say, here's a test case, you need to know what output you're expecting to get, okay? It's not a test case if you only have inputs and no expected output, because the whole point of the test is the input is producing the output, and the output matches the expected output, okay? So if you don't have expected output, it's not a test case, okay? So now that our expected outputs match now that our outputs match our expected outputs, then we can go on and we're gonna add, we're gonna do dx squared plus dy squared, and that's gonna be the distance squared, okay? And so we can just say, all right, is this what I'm getting? I should get 25, and indeed, right, 3 squared plus 4 squared gives us 25. So that's what we want. And then so the last thing we need to do is we need to take the square root of distance squared, and that will give us the distance. And indeed, when we run it, we get 5.0, okay? So this is just kind of the idea of coding incrementally, which I really, really, really want to strongly encourage you guys to get in the habit of, and not try to solve the entire coding scheme in one cell, okay, or in one session, right? Just build it incrementally, test it out before moving on. All right, and so so anyway, the name for using all of these print statements is called scaffolding, okay? It's kind of like when you build up a building. And then once you get it working, yeah, remove all of those extra print statements, okay? Remove all those extra print statements. It's a strategy because it works, all right? No shame in writing print statements everywhere. Okay. And then, you know, we can certainly simplify this a lot, right? Like this distance thing, we could rewrite it. Okay, it could just be written as okay. We could do this, and then we can further replace this quantity here with this, and this quantity here. So this will work just fine as well. Okay. And then we can just say return this. All right, and if I call okay, so this also works, okay, but this is a lot harder to read and decode than this, okay. So this is maybe more concise, but I don't know if but harder to read, okay, more concise but harder to read. All right, and then if you have a mistake like having y1 here, okay, and you get, wait, why am I getting this value? This is the wrong value, okay? Then you have to kind of read through this, and I think detecting exactly what happened and what went wrong in something like this is a lot harder to do than if you took your steps like this, okay? So yes, if you wanted to have all of your there's I don't know, I think sometimes programmers will get into like these weird ideas of like golf, in that they're trying to like write the code that works in the fewest lines possible. It's not necessarily a worthy goal, okay? The goal should be, most importantly, is you want code that works correctly, and secondly, code that you can read and understand, because chances are, if it's any kind of project, you're going to have to read what you wrote earlier, and if it's not easily read and if it's not well documented, you're going to be angry at yourself, okay? And it's not going to be a situation where you can call someone else up and say, hey, what were you thinking? Because what the problem is you won't remember what you were thinking 3 months ago when you wrote your bad code, okay? So get in the habit of writing good code and things like that. Okay, so anyway, the other strategy that's listed off in chapter 6 is composition, which is basically you build up bigger functions by calling simpler functions, right? So rather than rewriting code that does the same thing that another chunk has already done, just call the other functions, right? So here we want to create a function that's going to calculate the area of a circle given 2 points, right? So all we have to do here is we're going to use the we're going to calculate the length of a radius, okay, by using our distance function. So we're going to say radius is the distance function going from the center to the perimeter points. And then we're going to calculate the area based on the radius, right? So the radius is easy. I mean, the area based on the radius is easy. So we just do pi r squared. That's going to be the result. And then finding the area of a circle from the center to one of the perimeter is, we'll say, okay, the radius is equal to the distance. The result is going to be, you know, radius times the area, and then you can return the result, okay? You know, certainly this can be simplified by just saying return the area here. And again, you can simplify everything by just saying return area called on the distance from here to here. And that's something you could do, but it's not necessary, right? And so here you can call that on the coordinates if the center of your circle is 1, 2, or if the center of your circle is 0, 0, and you're going out to 3, 4, you know, we're going to get this area, right? Radius of 5, 5r squared, something like that, right? or if I do circle area from 0, 0, and then let's do math square root 2, square root 2. Okay, then our area is 4 pi. Okay. All right. Another thing that's going to be helpful is writing Boolean functions, and we talked about this briefly when we just talked about naming functions. But when you name a function, it's kind of convention says a function that's going to return a true/false value should be written as in the form of kind of like a yes/no question. Is divisible, okay? And so here we can say is divisible, is x divisible by y? And we're going to just use the mod function, right? X mod y, if that equals 0, we're going to return true, otherwise return false, okay? And so we can say, okay, 6 comma 4 is false, 6 comma 3 is 6 divisible by 3, that's going to be true, okay? Because the comparison operator of equal equal is a Boolean operator itself, I would argue that this is better, it's more concise and more readable, right? So if you define the is function this way, and you say is divisible xy, just have it return x mod y equals 0, okay? X mod y equals 0, and this is going to be more concise and readable than this, okay? I mean, this is not hard to read, but this is going to be a better choice there, okay? Return what the result of this Boolean operation, okay? And so here, once you have a Boolean function, you can use that in conditional statements, right? So we can say if is divisible xy, and then print this out, right? So we got x is 6 and y is 3. If that's divisible, print it out, and it's going to print out x divisible by y, right? This is a common mistake. It's not a mistake, but a common unnecessary thing is to write if true equals true, okay? This is completely unnecessary, right? So here, if you want to, sometimes students will write if is divisible equals true, print x minus, x is divisible by y. This is a valid statement, but this comparison operation of equals true is unnecessary, and it clutters your code, okay? This is not any more readable, and so it's better to just have kind of a, the result of the function and this will run if true versus if false, okay? There's no it's not necessary to write if true equals true, okay? This is an unnecessary thing to do, and especially if you write your functions, okay, your Boolean functions in the form of these yes/no questions like is divisible, your code is very readable, right? If is divisible, right here, if is divisible, then do this, then that's good, okay? All right, and so here we revisit the factorial function as kind of an example of recursion, okay? And so you can just start off just by writing an empty function that does nothing, and then we start off by writing the base case, okay? And in the base case for the factorial, when we get factorial 0, we're going to return none, okay? And here, if I try it out on factorial 4, it doesn't do anything, okay? That's kind of like I test out factorial 4. We obviously haven't coded anything up like that, right? And so, so here, if we get anything other than 0, we're going to make a recursive call, right? Which is basically that 4 factorial is going to be 4 times 3 factorial, and more generally, n factorial is n times n minus 1 factorial. And so here, I wrote it a little bit kind of verbosely, but we have the base case. And if it's anything other than the base case, we're going to just kind of do the recursion operator, which we're going to call factorial on n minus 1. And then the result that we return is going to be n times whatever we ran earlier, the factorial on n minus 1. And then we're going to go ahead and return that result. And so when we call factorial on 4, it gives us 24. Now, when you write recursive code, it's quite possible to run into some kind of loop. I mean, some kind of error, right? So pretty much all loops can be rewritten in some kind of recursive form, okay? But one thing that you can do is you can just, again, start inserting print statements everywhere to help you debug your things, right? So here, one thing to help you understand how the recursive operation is running, I run a print statement right at the beginning. As soon as the function is called, we write a print statement, okay? And then right before the function returns a value, we create another print statement, okay? So here, this print statement is for the function call, print statement for function call. And to help us visually see the print statements, okay, I'm gonna add a bunch of spaces, okay? 4 spaces for each value of n here, okay? And so this gives us a sense of, it kind of uses the formatting to help us see everything, right? So we have a print statement for the call and print statements for return values. And so we can see kind of each intermediary call that happens when we do recursion. So when I call it here, we can see it's going to run 4, factorial 4, then it runs factorial 3, factorial 2, factorial 1, factorial 0. And at factorial 0, it returns 1. Okay, factorial 1, it returns 1. Factorial 2, it returns 2. Factorial 3, it returns 6. And after factorial 4, it returns 24. Okay, so we get back 24. Okay, and then the last thing, and I'm sorry I'm going a couple minutes over here, is you can check for input types, okay? And so there's a function called isInstance, all right? And you can just see, is whatever value coming in, is it an integer, is it a float, is it, you know, a Boolean, and things like that. So you can say, is instant 5 an integer, is instance 5.3 a float, is instance true a Boolean, okay? Maybe I should just say false, something like that, okay? The other types are like strings and things like that, so you can do that. And this way we can kind of insert this right above my factorial statement, okay, or at the start of my factorial statement, just to make sure I don't get, we don't try to calculate the factorial like 1.5 and things like that. Oh yeah, quiz answers. Thank you for that reminder. Today's quiz answers, it's Friday. Okay, A for the first question and D for the second question. A for apple, D for dog. Okay, first question is A, second question is D, okay? All right, so these checks the values, and then we can just try, and then we'll call a return none to kind of just end the function there, all right? And so if we try to give it illegal values, it stops us, okay? Okay, so yeah, quiz answers are A for apple, D for dog. All right, that's it for today. Have a good weekend, you guys. I will post homework 2 up, okay? Homework 2 is coming, and I hope you guys have fun with homework 2. All right, so we'll see you guys. See you guys on Monday, okay? All right, stay safe, stay healthy out there.
Hi, Professor.
Mm-hmm.